Hello, welcome to the Tuesday, November 14th, 2017 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Vietnamese security company BKAV has released a YouTube video showing how researchers at the company were able to bypass Face ID on Apple's new flagship iPhone 10 by using a mask. Now, if you remember, during the introduction of the phone, Apple pointed out the process it went through to ensure that Face ID systems can be fooled, and masks were actually particularly pointed out as a way they tested. But like any biometric security system, a good enough representation of the features tested can be used to impersonate the users. The researchers had to go through a reasonably substantial effort to create a mask that worked. The face of the user had to be scanned via a 3D scanner to create a three-dimensional replica of the face. Then they colored parts of the face that the phone uses in its facial recognition algorithm. It helped that the phone will recognize even a partially obscured face. For example, if half the face is covered up or if the user does wear sunglasses, Face ID still works. So the mask only needs to imitate a partial face. The researchers stated that their attack, unlike others, worked because they looked closer into the way the Face ID algorithm is attempting to figuring whether or not a particular face matches. They state that the cost of the mask was $150, but this likely only includes the cost of printing the mask itself, not necessarily the time and cost in collecting the data necessarily to create the mask. They state that theoretically it's possible for an artist to create a mask based on regular photographs of an individual, but that's not actually what they did. So if Face ID doesn't work, what else is there for biometrics? Researchers at the University of Buffalo had another idea for biometric authentication. They developed a low-level radar system that can be used to identify heart movements, which are apparently unique enough to use them for authentication. They describe the signal power of the radar they're using as less than the power of Wi-Fi. It is in a fairly wide range between 2 and 20 gigahertz, I think is what they stated. So it can be a quite higher frequency than regular Wi-Fi signals, but they consider it harmless based on the signal power. The sensor does not need direct contact to the user. It can also be used to keep a user logged in while the user is in the proximity of the sensor. Like even with Face ID, you have to face the sensor. With this new technology, with this heart detection technology, you just have to be close to the device. You don't really have to face it. Now, this is just a prototype. They did a few dozen measurements, different individuals that they tested it on. It remains to be seen if this can be wrapped into a commercial viable package. One problem with the prototype system was that, well, in order to measure the heart movement accurately, you have to subtract any movement of the body. After all, you don't want the user to ask to stay still. In order to accomplish that, they actually needed two radar systems, one in the front and one in the back of the user. So this could be potentially difficult to implement in, for example, a mobile device. The other problem they looked into, but really that needs more work, is whether or not the signal is actually consistent over a longer time. Now, they looked at some things like, for example, accelerated heart rates, but then again, as people age, of course, their heart rhythm changes somewhat. So far, the only study they did lasted 2 months, so over that time frame, it was stable, but of course, that doesn't mean what happens in the longer term. And then I have an older talk here from Black Hat, but the slides I think were just made public, and it is something that, while I usually try to stick with very current topics, that really has been a big concern lately, and this is server-side request forging, or SSRF. Now, this happens more and more because more and more web applications, of course, require on connections to web services, and this has been a little bit an unappreciated security vulnerability. This vulnerability allows an attacker essentially to then create arbitrary queries and send them to these backend systems. And if you include not just sort of traditional web services, but also NoSQL databases like MongoDB or Elasticsearch, which receive queries via HTTP requests, well, then you're sort of back in SQL injection territory, but now using HTTP requests. Typically, to prevent SSRF, what the web application does is it validates the URL and then, of course, only allows certain requests to specific URLs. But what the paper and the presentation really points out is that validating URLs isn't really that easy, given the wide range of content that can be included in these URLs. And in addition, well, with some libraries, actually invalid URLs will work as well. And of course, how they are then being interpreted is not necessarily consistent or easy predictable. In the presentation, what they did, they looked in particular at Python. I think that was the most interesting example they had. They had multiple examples, not just Python. But in Python, you have URL-lib. URL-lib is a library that can be used to validate URLs, and that's how you typically do it. In addition, you have the request library, which is then used to send HTTP requests. The problem is that these two libraries don't quite agree in how they actually parse URLs. So, for example, by adding spaces in URLs or using two colons and tricks like this, you may be able to have URL-lib verifying the first part of the URL, well, actually the second part of the URL after the space is then being used by the request library to make the request to the backend service. So pretty interesting vulnerability, and if you are looking in web applications, either from a defensive or an offensive point of view, you definitely should flip through this presentation. There's also, not from Black Hat, I think the talk was given by the same person at Hack in the Box. There's also a YouTube video with this presentation. Well, and that's it for today. So thanks again for listening, and talk to you again tomorrow. Bye.